All right, well, good afternoon, folks. Thank you for joining us for this virtual field day. We're thrilled to have with us today a couple of our researchers looking at cover crops here in Iowa. But before I get to their introductions, I will introduce myself. For those of you that don't know me, I am Liz Ripley, the Conservation and Cover Crop Outreach Specialist with the Iowa Learning Farms. We are based on campus here at Iowa State University, established in 2004 with the goal of building a culture of conservation. So working with farmers, landowners, agency partners, and researchers like those featured today to implement practices that improve water quality and soil health while helping them remain profitable farming systems. And this is all made possible through partnerships. So today I'd like to give a thanks and shout out to the Iowa Nutrient Research Center who funded this particular project and this virtual field day. Additional partners of the Iowa Learning Farms include our Iowa Department of Agriculture and Land Stewardship, the USDA Natural Resources Conservation Service, Iowa State University Extension and Outreach, our Iowa Department of Natural Resources, US EPA Section 319, Growmark, Conservation Districts of Iowa, and the Iowa Soybean Association. So as we go along today, in just a moment, we will be featuring a video from the fields talking about this innovative research project. While that's playing, feel free to submit questions to me in the chat. Following the video, we'll have an opportunity to dive into some of the data a little bit and have a Q&A with our presenters. And this field day is the start of the conversation. It's an exchange of ideas, and it's important to network with fellow farmers and landowners to continue to share and learn ideas. So after today's virtual field day, you will be receiving an email with a brief evaluation and a link to this recorded field day. So we encourage you to fill out that evaluation and then share this link to the virtual field day with others who may be interested. So our speakers today include Alison Robertson, Iowa State University Plant Pathology, Entomology, and Microbiology Professor, and Peter O'Brien, U.S. Department of Agriculture, Agricultural Research Service Research Agronomist. So with that, we will head to the field and take a look at this cover crop project.
Hi, I'm Alison Robertson. I'm a field crops extension pathologist at Iowa State University, and my lab has been working on cover crops for the last 10 to 12 years. We started working with Tom Casper. Tom had a question about why we sometimes got reductions in yield of corn when it was following a cereal rye cover crop. And so he approached me and he asked me if seedling disease could be playing a role. And so we got together and we got some funding from Iowa Nutrient Research Center, and we started to investigate if corn was more at risk for seedling disease following a cereal rye cover crop. So Tom and I started to work together to try and understand why we were getting this yield reduction with corn following a cover crop of cereal rye. We knew that there were a lot of farmers out in the state who were hesitant to plant corn or hesitant to even try cover crops because they were worried about their corn yields after those cover crops. And so we really wanted to get to the bottom of what's happening in the system. And so I started working with Tom, and now for the past 10 to 12 years, we've been working in the system, trying to understand what are the factors that are playing a role so that sometimes we see this yield decline of corn following a cereal rye cover crop. And I'm a pathologist, so I'm interested in seedling disease. And one of the first things we did was we were able to show that cereal rye is a host of seedling pathogens that can also infect corn. Because of that, our first experiment that we did was we wanted to look at, could we separate the cereal rye from the corn in time? And so what I mean by that is, what happens if we terminate the cereal rye at different dates before planting that corn? Can we reduce the risk of seedling disease, and can we mitigate that yield drag that we're getting? And so from our first set of results, we were able to show that yes, we could, by separating the corn in time from the cereal rye, we could reduce the amount of seedling disease and we could mitigate that yield drag. So from that, we came up with a recommendation that a cereal rye cover crop needs to be terminated at least 10 days before we plant corn. The problem with that recommendation is that sometimes a farmer can't get into the field to terminate the cereal rye 10 days ahead of planting the corn. This year is a perfect example of that. And so the next set of experiments we did was we looked at how does planting green affect corn and that corn yield drag. And what we were able to show is that when you plant corn into a green cereal rye crop and then you terminate that cereal rye at or soon after planting, that you increase the risk of seedling disease and you also get yield drag with that. In this trial that I'm standing in front of today, that was one of the treatments that we have in this trial is planting green. And so behind me, you can see the cereal rye. A lot more biomass than we ever expected, thanks to an exceedingly warm February, and then rain the last 4 weeks, which meant we couldn't get into plant. But a lot of biomass here, and we know that that is going to increase our risk of a yield drag, and we're probably going to see more seedling disease with that. In case you're wondering, we had no problems planting corn into this much cereal rye biomass. So planting hasn't been the issue. I'm really interested to see how what the crop will look like in another 4 to 6 weeks, because I don't think it's going to look that great. It's corn, right? Corn is a princess. Soybeans, fine. They're so resilient, but corn, yeah. Corn is a princess. So I talked about how we can reduce disease by separating a host crop from the pathogen in time, but we can also separate the host crop from the pathogen in space, right? And we know the pathogen is coming from the rye roots, okay, and coming onto the corn. That's what our previous research showed us. And so we did some work, again funded by Iowa Nutrient Research Center, where we socially distanced the corn from the cereal rye. And we were able to show that by socially distancing the two crops, that we reduced or we mitigated the yield drag, and that was associated with lower seedling disease as well. You're probably wondering how we socially distanced the two crops. So we drilled the rye, and then what we did was we plugged one of the drills, and so then we had 3 rows of rye planted, and then we would have the drill plugged, and in that row where the drill was plugged, that's where we would plant the corn. So if our corn's on 30-inch rows, we have 3 rows of rye running in between that. That means the corn is separated from the rye by about 3.5 inches. We're drilling on 7.5-inch rows. Then another thing we did was we plugged 3 of the drills and then just plant, and so that meant that we were now planting the rye on 30-inch rows. So when we plant the corn immediately in the middle of that, now the corn is 15 inches away from the rye on either side. When we did that, we had as much seedling disease as we did in our no rye cover crop, and our yield was almost as good as where we had no cover crop. So we were really pleased with those results. But the problem with that experiment is, why are we planting cereal rye? We're planting cereal rye for all the benefits that it gives us, right? It protects our soil from erosion, improves infiltration, takes up that excess nitrate in the soil. And if we're going to socially distance the rye from the corn, if we're planting rye on 30-inch rows, that means we're planting 25% as much rye as if we'd planted, on 4 drilled rows every 30 inches. And when we're plugging one of the drills, then we have 25% less rye on the surface. And so because of that, we were just concerned that recommending to farmers that they plant rye on 30-inch rows, right? we might be negating the benefits of that cereal rye. And so I got together with Peter O'Brien. Peter is a research agronomist, but he's able to study things like infiltration and erosion. And so we got together to work on this project that I have here behind me. And so what do we have in this project? So in this project, we have the rye socially distanced from the corn. We have the rye planted in 30-inch rows. And then we also have where we've plugged one drill. And so we have 3 rows of rye in between the corn. So we've socially distanced it. But then the other thing that we wanted to do was we also wanted to plant green or terminate at least 10 days before planting the corn. So put in that timing. Because what we're hoping is by socially distancing the rye, we can then plant green, because that would be really helpful to a farmer, right? If he just he can terminate and plant on the same day. And so that's the goal of this experiment behind us. We're trying to see, can we socially distance, still plant green, mitigate the yield drag, and reduce the amount of seedling disease. So the kind of data that we're going to collect to see if this is working is we're going to come out at about V2, V3 is when we normally like to come out. We dig up seedlings then, and then we wash them, and we look at the roots and the mesocotyl for symptoms of root rot, which would be seedling blight, right? And we'll also do stand counts to see if we lost any stand from seedling disease. Other things that we'll be doing is just measuring the height of the corn, biomass of the corn, looking at greenness of the corn, measuring that, and looking just to get a measure of how vigorous that corn is. Towards the end of the growing season, we'll come in and we'll count plants with barren, so no ear or very small ears, because you can imagine if you get a small ear or no ear, that reduces your yield, right? So we'll also look at stalk rot, and obviously we'll collect yield data as well. So when we collect this kind of data, we collect it from a known area in the plot. So for example, we'll collect cereal rye biomass. We'll collect it from a meter of row, just over 3 foot of row. And then depending on how much biomass we have in that meter, we're then able to convert it to how much biomass would be on an acre. So the same as when we go out and we collect our seedlings. We'll collect our seedlings from a meter of row. We'll collect 5 seedlings. We'll find out what the average root rot is, and then we'll be able to come up with an average root rot per acre for that field. Now I've talked about the pathology and the agronomy in terms of corn growth that we're doing, and I'm going to hand off the mic now to Peter O'Brien, and he's going to talk about some of the data that he's collecting.
Hi, my name is Peter O'Brien, and I'm a research agronomist with the National Laboratory for Agriculture and the Environment, and that is located on Iowa State University's campus, and it's part of the USDA Agricultural Research Service. And a lot of my research program investigates cover crops and what sorts of benefits and, of course, potential drawbacks come along with that. Yeah, so I got involved with this project because I came in and took over the research program of Dr. Tom Casper. And he did a lot of really good work denoting the benefits of cover crops in our corn-soybean systems. But they also showed, as Alison described, some potential for yield drag. And what we really want to do with this project is determine what is causing that yield drag, and if the strategies that we're employing to try to mitigate that are doing anything to the benefits that we see from the cover crops. So some of the benefits of cover crops, as the name implies, it's covering the soil. And so it's protecting that soil from intense heat. It's changing the way that water evaporates from that system. So maybe you're holding a little more water. It protects it from raindrop impact, and so it's not breaking up the soil particles and risking erosion. Also slowing down on slopes, it's slowing down water movement, and therefore improving infiltration. Another really valuable benefit of cover crops is just the active root growth that's going on, and so it's promoting a lot of soil health characteristics with those different pore networks. And so in addition to increasing infiltration, sometimes it's able to increase the amount of water the soil can store. And so in a year like this, when we get a lot of rain early in the season, hopefully beneath that cover crop, it's holding onto that water that then the corn can use when it needs it later in the year. So some problems we have this year with this really large amount of rye biomass that we've grown is, I talked about some of the benefits of having the cereal rye for water, but when we grow this much, we worry that maybe it's taken up too much water. So maybe too much of a good thing, that it might deplete the soil of water from the corn. There's also a big risk of once this cereal rye all dies off, it lays down on the soil, it's decomposing over the course of the year, and sometimes that can mess with nitrogen dynamics and then kind of hurting the corn in terms of nitrogen availability. So Dr. Robertson did a really good job describing how we can mitigate crop yield declines by strategically managing the cereal rye, by either spatially separating it or separating it in space. But in both of those circumstances, we are either reducing the amount of rye we're putting onto the field by 25% or 75%, or we're reducing the amount of time that rye has to grow in the spring. And you can see out here, or in some of the B-roll, we can see in this trial that even that 2.5 or 3 weeks of growth in the spring can result in huge biomass increases. One really important way to determine if the rye is providing these ecosystem services, despite changing our management, is to measure just how much cereal rye is out here. And so as we have more cereal rye biomass, again, it's capturing more of that nitrogen from the soil profile, keeping it out of the tile drains, which is where we do not want it, and then holding it there on the field for the corn later. So we collect rye biomass immediately before termination. So for this trial, we collected at 2 different times because we terminated at 2 different times. And we expect to see really big differences in those rye biomass numbers this year. In addition to measuring how much rye biomass is there and actually how much nitrogen is within that biomass we collect, we also buried some little PVC resin lysimeters. And so what that's going to tell us is any amount of water that's going down into the soil profile, about 2 or 3 feet is where we buried them, water that goes through that lysimeter, nitrogen is removed from that water and held in the resin. And so this is kind of acting like a proxy for what might be lost through the tile drain. And so that's, in this area, a really important concern and a really important consideration for why people grow cover crop. Yeah, so in year 1 of the experiment, we found not as exciting results as we might want to see with our different strategies for the rye cover crop in terms of nitrogen in those resin lysimeters. But what we did find was at least one important finding, that having a cover crop of any sort, separated, not separated, early terminated, late terminated, resulted in a reduction in nitrogen in those lysimeters and therefore a reduction in nitrate losses in the tile drainage. So in addition to understanding what's going on with nitrogen dynamics, we really want to assess how well these different strategies are allowing us to reduce soil erosion, which is a really important benefit of cover crops. And so we're going to come out a week or 2 after corn planting, and we're going to conduct rainfall simulations. And so we're going to rain really pretty intensely on these plots, both the controls with no cover crops and across the spectrum of our treatments. And we're going to be collecting how much water comes off, so we can kind of understand things about runoff and infiltration. And then we're going to see within that water how much sediment is there, how much soil is moving down the slope, and to kind of understand our protection from erosion using these metrics. So this project is a really exciting one to be a part of because it's starting to get at some of these questions that are creating barriers to adoption across the state. People are concerned about, if I'm planting cover crops, am I hurting my corn yield? Am I changing nitrogen needs in my soil? And so by expanding on our current knowledge of what we know in terms of yield disease, what we know in terms of cover crop benefits, we're kind of building this toolbox for different situations. Farmers have different needs. So if we can identify some different strategies for them to employ and understand what's going to happen, that's a really exciting thing for us and a really useful thing for the growers in the state.
All right. So I know Peter's got some data to share, but just a reminder, if you have questions for our presenters today, feel free to submit them in the chat. As we get through some of this data here from this past year's collection, we'll have an opportunity to chat with our speakers today.
Right. Thanks, Liz, and thanks everyone for tuning in. Yeah, we just have a few slides to kind of follow up on what was shown in the video, to see what actually happened this last growing season, which was really atypical with all of the rain and the really late termination. And so we'll call it a boundary condition, but we'll get to that here pretty shortly. I do want to start off just kind of sharing kind of the treatment structure again. We described it in the video, but sometimes it's kind of complicated and nice to be able to see a picture of it. So just kind of as a reminder, we're talking about kind of this would be like your conventional usage of the cover crop, where we're just drilling it on 7.5-inch rows throughout the whole field, and either terminating it early or late, depending on what works for you in that given year. Kind of then the different social distancing approaches we're using, or that skip row, and they had a really neat little figure in the video too, which was helpful. But just looking at here, you see the little rye plants all the way across the corn row. Here we see the rye plants in the inner row, but not on that corn row. And then over here we see just the really wide spaced rows. So this is kind of what we're working with in the next few slides, where we're going to talk about results. And then again, we did have plots that didn't have any cover crop in it at all. So one of the big things we keep harping on with this study, which is both exciting and a little frustrating, is the years were incredibly different from each other. So this was, I guess, the third year of the experiment, but the second year with these 6 treatments in place. And you can see in 2023, the rye biomass was much lower than in 2024. And we can see, I guess in the scheme of things, that 2023 was a slightly below average year, but pretty close, and 2024 was just an outrageous year. So if we look at just the biomass numbers, kind of what we're looking at in terms of boundary conditions is, this is the standard no skip row, late terminated drilled cover crop. So we'd expect this one to be the highest in all treatments. And then over here, with the lowest planting density and the shortest amount of time to grow, we'd expect that to be the lowest. So in 2023, everything worked out, right? So if you plant it in really wide spacings, it really reduced the biomass in that year. And then the skip row, you could increase it pretty well. And with that late termination, almost nearly match kind of the conventional approach. In 2024, everything went out the window. You can see things, 5, 6, 7 times higher. Over here, 40, 45 times higher. And so this was really kind of obscene and kind of a worst case scenario in some instances. But it was kind of an interesting kind of academic approach to think about what is limiting rye growth in the spring. And so we can see that the late termination in both the skip row and the really wide space rows actually outperformed the more evenly dispersed, higher planted density. So that extra space, they could really take advantage of that and create even more and more biomass. So what became of that biomass, or what did it do to the rest of the system? Thinking about corn seedling disease, the data lines up really nicely actually between the 2 years, just about the only thing that did. But you can see in our no cover crop, we're seeing 2 to 3% disease occurrence in those corn seedlings. And then in 2023, again, we're looking at these boundary conditions, where we expect the most disease here, probably the least disease here. And it shakes out pretty closely that way both years actually. So even with all that additional biomass, the percent of seedling disease occurrence really didn't increase all that much. And it was really exciting because our mitigation strategies were quite effective at reducing yield disease or seedling disease, especially that wide space rows, but even the early termination here kept it down. And even just that skip row, while it was a little bit higher than some of the other strategies, it was much lower than the conventional kind of positive control, we call it. Uh, yeah, that's what we got there. Corn yield, kind of the big one that maybe everyone wants to start with. 2023, no difference across any of the treatments. And again, that's not really atypical, and Alison touched on that in the video a little bit. We don't see yield decline every year, and we don't see it in every field every year. And so there's a lot of factors contributing to it. Seal disease is one, nitrogen dynamics is one, but there's a multitude of other things it could also be. And so in 2023, we didn't see any difference between the no cover crop and any of the cover crop treatments. 2024, we in fact did, pretty incredibly so. Just generally, because of the growing season, yields were a little bit lower in the no cover crop as well. But if you look at this positive control where that had the most cover crop coverage and planting density, yields were cut in half, which is a terrifying thing in a lot of instances. And that occurred both in this drilled, fully drilled treatment, as well as even with that skip row, it really didn't help all that much with the late termination. But we're seeing with yield, there is an important distinction between early and late termination, where we're seeing that in both of the cover crop treatments, if we let the cover crop grow later in the season, we're more likely, or at least in this year, we saw those differences. And again, that goes back to seedling disease as one contributing factor, but there are other things playing into it, especially nitrogen dynamics, especially changes when there's so much biomass in soil temperature and water dynamics. All of that's playing a big role in causing those yield declines. We put summaries there. Yeah, so some of the other ecosystem services that we were interested in, we saw the rainfall simulations going on. Kind of interestingly, we didn't really see a significant difference in infiltration between any of the cover crop treatments. But we did see a difference between no cover crop. So any amount of cover crop is increasing infiltration compared to the no cover crop control, right? And that lines up with the resin lysimeters that we were speaking about in the video. But the interesting part of the rainfall simulations, which we're really glad it worked out, and having so much biomass that year really emphasized the differences between the treatments, where we were seeing almost no erosion in 2024. There was just so much biomass out there. It's blocking water movement, blocking soil movement. So it's really doing what we want it to do out there, across all of the treatments. And especially if you'll think back to the rye biomass, these ones that were having the most biomass. So that was really exciting. Depending where you live in the state, what your field looks like, erosion is often cited as the #1 reason for having cover crops. So these are all doing the job there. And again, in 2023, the variability was really high, but again, it came back to the idea that any amount of cover crop is better than no cover crop. And then differences within the treatments were kind of hazy, but which was actually really good for us thinking about using it in different ways, that if we do want to plant less of it or terminate it at different times, it's still providing, a fair bit of benefits that we want it for. Yeah, and so those are all the results slides we have right now. Of course, we're happy to answer questions, but yeah, kind of as a summary, a lot of it went into, a lot of our interest is looking at the different cover crop treatments and termination timing and spacing, which was really evident in the rye biomass and corn yield, and seedling disease data, but some of those ecosystem services and some of those other benefits of cover crops, it was really pretty binary where you have a cover crop, you get it. If you don't have a cover crop, you don't. Which again was a really exciting finding and a little bit unexpected, but I think good for again thinking about that toolbox and what we had to use in different situations. Uh, so that's all I have to share. Um, Liz, we can open up for questions, I guess.
Yeah, great. So the first question that came in here is specifically about equipment, but would a drill with 10-inch centers and plugging every third one be a reasonable compromise to the spacings presented? So you're working on a 7.5-inch, they have a 10-inch, so having 20-inch spacings.
Yeah, I mean, from what we saw really in both years, I think the spacing is not an exact science and it probably doesn't matter all that much. So I think it would result in very similar outcomes.
Agree.
And so I think I can kind of allude to this one too. Obviously, your plots are pretty flat and square, but in practical terms, with contours and terraces, how does one get the drilled open spaces to fit with planter rows? And so RTK would be probably the important tool for making this work. So
Yeah, I think
GPS.
yeah, I think that's absolutely right. We are yeah, our lives are a little bit easier than out in the real world where we have our square straight lines. So we deal with a little bit different problems. But yes, I think with GPS and those other tools, there are options out there to simulate what we did at least.
So this person commented that they're also afraid of cereal riot before corn, but have heard that winter wheat might be less aggressive, that's a better choice, or maybe triticale. But as a landowner, they do want spring growth. And so far, winter camelina and rapeseed have not worked out for the best. So any comments on different species? I know this is focused on rye, but thoughts on other species?
Yeah, we've done some work with winter wheat and not me personally with triticale, but some previous scientists have done that and um, I think that generally they grow a little bit less robustly in the spring and they're a little bit less winter hardy. So cereal rye is kind of the most common one because it's really winter hardy, it's really consistent, and it produces a ton of biomass in the spring, which isn't to say some of those other um, overwintering crops couldn't do the same job. Um, I we've had similar problems with winter camelina and other trials that it doesn't overwinter, it doesn't produce much biomass in the spring. I don't know if Allison's done any work with seedling disease with some of those other crops. I'm not sure.
We've done a little bit of work with those other crops, but just in the greenhouse where we looked at seedling disease following winter wheat and triticale, and we saw the same problem with those grass covers as well. So the fact that there might be less biomass with them might mean that there would be less seedling disease, but yeah, there's still hosts of the pathogens, and there's still going to be a risk for that corn.
All right. Can you speculate how the wet weather in the spring of 2024 affected seedling disease, nitrogen availability, and corn yield ultimately?
Sure.
Now, putting aside your data and analysis, but speculations here.
Yeah. Well, we don't really have to speculate on seedling disease because we did have some information about that, but seedling disease is also kind of tied in with plant stress. So if the plant's stressed, it's going to be more susceptible to disease. Um, I think that my speculation for 2024, which again is really atypical, was that just the huge mat of biomass laying on top of the soil surface was almost the worst thing for it. I think, there's weird things going on with nitrogen and water underneath the surface, but um, like allowing basically heat to get to the soil is really inhibiting the crop's early growth and then changing, how that soil is drying out really affected it. And again, both of those things, soil temperature and soil water, are changing nitrogen dynamics as well. So it's kind of hard to separate one thing from the other. But I think just the huge amount of biomass we saw, that barrier was the biggest factor this year.
And in terms of seedling disease, the seedling disease that we most often see in corn following cereal rye is caused by Pythium. Pythium is a water mold. So when we have saturated soils or at least high moisture soils, that means that Pythium is triggered to produce spores that then swim in that water to the corn roots and infect the corn roots. So I would say that just by having wetter soils, we increase our risk of seedling disease.
Okay, so maybe this is in addition to once this you have your final year, I think that coming up this year, but in your erosion study, did you put any financial figures with the value of the topsoil? So maybe something to consider. How much money would you save by reducing erosion?
Yeah, no, we haven't, kind of short answer. And that's not something that we really dive into most of the time, is economic analysis, but it's obviously always at the front of everyone's mind. Um, our our study really showed differences in erosion, but the conditions in which we have it are really unusual. So it was basically like a 150-year storm. So it was 6 inches of rain in an hour. Um, and so we could put figures to those, kind of as they suggested, but I don't think they'd be realistic for what might actually happen. Um, and erosion's going to be changing with different rainfall intensities, but we wanted a really extreme one to highlight the differences between the treatments, and they are there, and we would expect that with different rainfall intensities as well.
And staying on that erosion, there's a request here if you can talk about the difference between inter-rill erosion versus rill erosion, that erosion from overland water flow and how cover crop affects it.
Yeah, the way that the cover crop is helping with erosion is kind of twofold, and I think it affects both forms of erosion. Is that like the plant itself is standing there, and so it's physically blocking water going over overland flow. It's also providing a cover from raindrop impact, which is reducing dislodging sediments from the soil surface in the first place. Um, and then it's kind of fourfold. And then the rainfall is all, or the cover crop is also, in most cases, changing the soil structure to make the soil more resilient to erosion to begin with. It's creating stronger aggregates as well as emphasizing more erosion. And so it's kind of like a four-factor attack at erosion, which is really kind of notoriously hard to measure to begin with. But I think those things all are playing together in our study. I don't know if that answered the question.
There's a question here on the corn management on the nitrogen side. How much nitrogen was applied, how or when?
Yep, so as a split application, there is basically 40 pounds applied at planting, and then we side dressed based on the late spring nitrate test. So it was kind of a variable rate depending on soil testing at early July, late June.
Since wheat and triticale are less cold tolerant, could that lead to needing to wait for even warmer weather to get a good termination, extending the corn planting date even later versus cereal rye?
Yeah, it very well could. Um, yeah, because if it takes too long to green up and start actively growing, you're not going to get a good kill. And you're also not going to get much biomass production, which is the whole point anyway. So yeah, it's kind of a little bit of a lose-lose, but I think most springs, like winter wheat, would do okay in central Iowa. It's not quite as prolific as the cereal rye.
So a question here about disease, kind of maybe rough numbers, but how much disease is there if I plant corn drilled rye that doesn't get over 12 inches high versus anything taller? They specifically terminate right after planting. So
Can you repeat that, Liz, please?
yeah, so they're terminating right after they plant, but their rye is only about 12 inches high, ideally. So what might be the difference in corn disease versus anything taller than that? So if they're going by height versus date.
Yeah. So we've 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 been part of a big study called the Precision Sustainable Ag Study, where we looked at the effect of rye termination on 16 states across the US. And I know Rochelle is on here, but I'm pretty sure that we have a pretty good correlation between seedling disease severity and biomass. So the more biomass we have, the more severe our seedling disease is. So when you're keeping when you're terminating that rye biomass at 12 inches or below, that's going to reduce your risk of seedling disease. And I know Stefan Galens has also done some work looking at the relationship between rye biomass and yield drag. So yes, I definitely think that biomass, the amount of biomass plays a role in how much seedling disease you're going to have.
And kind of while we're talking about that, maybe this is more for Peter because we're talking nitrogen dynamics, but you mentioned the large amount of rye biomass potentially changing those dynamics over the course of the season. Could you elaborate a little bit more on that? Maybe what you were finding in your resin lysimeters?
Yeah, well, those are kind of two different questions, but kind of the holy grail of cover crop research in a lot of ways is understanding when the nitrogen that's held in the cover crop is released and available to the corn. And that's kind of a big unknown at this point. Um, and kind of the way that it can change nitrogen dynamics that we're worried about is if nitrogen in the soil or nitrogen that we apply is going towards degrading that cereal biomass, then it's not available for the corn. And so in a lot of cases, people will recommend applying additional nitrogen more than you would normally do, especially at planting, for a cereal rye cover crop. Just because there is the competition between the corn roots, and then the microorganisms that are degrading the rye biomass. And it's related to, but not exactly the same as the idea with the resin lysimeters, which is that is kind of a proxy for how much nitrogen is actually being lost out the bottom of the soil profile down to the tile. And so for corn nitrogen dynamics, what's going on at the soil surface is really important. For the environmental quality side of things, what's going all the way down through the resin lysimeters is really important. And one things that rye cover crop has been really consistent at for many, many years, we've shown in a lot of different ways, is reducing that nitrogen loss down in the profile. And a lot of that comes from active growing roots when the rain is really happening and when the most drainage is happening. So our resin lysimeters were really effective in 2024, or the cover crop was really effective because it rained a lot and the rye took up a lot. And so the no cover crop treatment in 2024 was way higher than any of the cover crops, and we didn't have that data to show, but it was really, really effective. So kind of wetter springs make those the cover crop more effective at keeping the water out of the nitrogen out of the tile drains.
Um, so I know, Allison, you've kind of looked at this or have a project in works on this. How helpful would harvesting the top growth for forage be for mitigating the effect on corn yield when top growth gets excessive?
That's a great question, and you're right, Liz. I just started a big experiment, Peter and I, with Mark Licht and Marshall McDaniel. And what we're doing in that experiment is we're looking at the contribution of shoot biomass and root biomass to nutrient recycling, erosion, infiltration, seedling disease, corn growth, etc. So we just finished 1 year of that study. We just finished the first year. And and we haven't really got around to organizing all that data yet, but I think that would help. If you could remove that top biomass, getting to that whole thing about keeping the biomass on the surface remains cooler and wetter. That's more favorable for Pythium. So yes, I think that if you remove the shoot biomass, it's going to help with mitigate that yield drag, mitigate the seedling disease.
Yeah, what do you think, Peter, in terms of
No,
agro ecosystem services?
I'm certainly not going to stray into speculating about disease. Uh, but yes, I think the it's going to be really neat to see what the contributions are. I think the biggest difference is going to be in the nitrogen dynamics that we were talking about of root biomass and shoot biomass and how those degrade over time and keep things available to the corn, especially under the different conditions as you described, where um, the soil surface isn't covered. When we remove that, then it's warmer, it's drier. All that stuff's going to play together, so it's exciting.
Yeah, and there's definitely a question in here that's going to be tied into that. So maybe that's a future webinar virtual field day. We can come back to that project as we look at this relationship between shoot and root biomass and all these factors tying in that we've been discussing today. So we've talked about spacing, we've talked about time, but how is that all interacting with the biomass that's there? So, so a couple other questions that have come in. So the spacing was one thing, but what was your targeted seeding rate? What was your goal of seeds per acre on this?
For the rye,
Yeah.
oh gosh. So we do it based on mass per area. So it was like 60 pounds per acre for the fully drilled, and then what, 45 pounds and 15 pounds then.
And then any specific variety planted?
Yeah, we use Elbon rye for a lot of our studies, but it's not necessarily better or worse. There's a lot of the different varieties have shown similar performance in central Iowa at least.
All right. Well, keep those questions coming in. I have a few more slides I'd like to share with folks today. So we'll get those shared here. So for those of you that are joining us for a CCA credit today, please feel free to email me. My email is there on the screen, and I will also put it in the chat momentarily. But if you could send that in by 5 o'clock today with your name, the name you entered to watch today's virtual field day, if it's different, and then your CCA number, and I will get that submitted tomorrow to the CCA board. If you are interested in a potential edge of field practice like a wetland, oxbow, bioreactor, or saturated buffer, I'd be happy to connect you with our Iowa Department of Agriculture and Land Stewardship. Again, you can either put your name and number in the chat, or you can email us directly at ilf@iastate.edu at any time, and we'd be happy to make that connection. And for those of you that have attended some of our other virtual events, this is probably very familiar, but if you have not done so yet this year, I encourage you to fill out our voluntary demographic survey. You can either do so by scanning the QR code on the screen here, or submit that via iowalearningfarms.org/survey. If you've already done it once for either a webinar or a virtual field day this year, you do not need to submit again. But again, it's a voluntary demographic survey for USDA funded programs. So we appreciate those of you that have done this for us so far already. And then I hope you can mark your calendars for 1 month from today, March 13th at 1 p.m. Central. We will be evaluating rotations of cover crops and summer annual forages. So we're taking a livestock focus on cover crops here in about 1 month. So with that, let's see, I've got a couple more questions I think that have come in. So that's where I got a question here looking at grazing. So I think join us next week. I'll have my grazing experts with us talking about some of the different species and implications of that. But I think in terms of this, if we added in the grazing, I think it would be similar to the forage, removal of that shoot biomass, especially if you can set up some sort of rotational swath grazing where you can make sure that they're focusing and really grazing that down as they move through the field system. They're both nodding their heads. Yes, agreeing.
I agree.
So thank you all for attending today. I will share up that CCA slide here momentarily and put my email in the chat for everyone who wants to submit that. I can happily get that submitted on your behalf. And just want to thank Alison and Peter for joining us today and sharing this great research project. You have at least one more year, correct?
Well, we've done after 2 years. We're
Okay.
hoping to get funding for a third year, just
Okay.
because we had 2 completely wonky years. So
Yes. Hopefully a normal weather year. At least
Yeah, we
today.
need a
Yes.
tiebreaker.
Yeah.
Yeah.
This February is nothing like last February. That's for sure.
Yeah.
As we're sitting at negative degrees here today versus warm weather last February. So,
Yeah.
all right. Well, let me get that CCA slide back up here for those of you that would like that. And again, any final words, Peter or Allison, as we wind down today's virtual field day?
I don't have
Thanks.
anything to add. Yeah, thanks for coming. Feel free to reach out with any additional questions or comments or anything. We'd always love to hear from people.
I totally agree. So thanks for taking time out of your day. I know we're all busy, and if you have any thoughts or questions, we'd be very happy to answer those. So thank you for having us, Liz.
My pleasure, and thank you for joining us. And stay warm out there, everyone.